All right, let's talk about a huge, kind of hidden threat that's lurking in the digital world. It's called a software supply chain failure, and it really boils down to one scary question. Are the apps you use every day built with poisoned bricks? Let's get into it. To really wrap our heads around this, let's start with a really simple but powerful idea. Imagine you're building a house. Now, you're not out there firing every single brick in a kiln yourself, right? No, you get them from all sorts of suppliers. But what if? What if one of those suppliers sneaks a few bad bricks into the shipment? Poisoned bricks. The house might look perfectly fine from the outside, but that core weakness, it's built right into the foundation. The entire thing is unsafe. That's the idea we're going to be digging into. So what does this actually mean in the tech world? Well, here's the textbook definition. A software supply chain failure is when the risk comes from those bricks, the third-party software, the libraries, the tools that are used to build the final application. The problem isn't with the architect's blueprint, the main code. The problem is that the materials themselves were bad from the start. Okay, to really get why this is such a big deal, we have to look at how modern software is actually put together. Because here's the key thing, it's probably not how you imagine it. You see, developers these days, they're more like master assemblers than they are old-school authors writing a novel from scratch. Instead of typing out every single line of code, they pull in these amazing pre-built components to handle all sorts of common jobs. Things like processing a credit card or showing a fancy graph. It's way more efficient, for sure, but it means they're putting a ton of trust in code written by people they've never even met. So the big question is, how did these poisoned bricks actually get into the supply? Well, attackers have gotten really clever about this. There are four main ways they sneak their malicious code into the software that we all depend on. Let's break them down one by one. First up, we've got a really sneaky trick called dependency confusion. So imagine a big company has its own special private brick they made in-house. Let's call it Project Internal Widget. An attacker comes along, creates a malicious package, and gives it the exact same name, Project Internal Widget, but they publish it to a public library. The automated build tools can get confused, see the public one first, and pull that in instead of the safe internal one. It's a brilliant and totally devious case of mistaken identity. The second way is a lot more direct. Here, attackers just build something that looks genuinely useful. They offer it up for free, but it has malware hidden deep inside. A developer might be searching for a tool that, say, formats dates really nicely. They find one, plug it in, and it works perfectly. But what they don't know is that in the background, it's also quietly stealing their secret keys and passwords. It's basically a digital Trojan horse. The third method, it targets the factory itself. In the software world, this is called the CI/CD pipeline. You can just think of it as the automated assembly line that takes all the code, all the components, and puts them together to build the final app. Now, if an attacker can hack that assembly line, they can inject malicious code into every single thing that comes off it, even if all the original bricks were perfectly safe to begin with. And last but not least, we have good old-fashioned neglect. This is basically like a builder knowing a batch of bricks was recalled because they're faulty and using them anyway. Developers will sometimes use older versions of software libraries that have known publicly documented security flaws. Hackers are constantly scanning the internet for apps using these vulnerable old parts so they can attack them. And the Log4j disaster, that was a massive, devastating example of exactly this problem. Now, I want to be clear, this isn't just theory. We've seen what happens when this goes wrong in the real world, and the results can be absolutely catastrophic. The SolarWinds attack is probably the most infamous poster child for a software supply chain failure. And this is where you might be thinking, okay, but how bad can it really be? I mean, it's just one bad component, right? One poisoned brick can't bring down the whole neighborhood. Can it? Oh, yes, it can. In the SolarWinds case, hackers broke in and corrupted a single software update. Then, when thousands of their customers, we're talking major corporations, government agencies, installed that trusted, legitimate-looking update, they unknowingly handed the attackers a key to their front door. The ripple effect was just staggering. And that just shows you the cascading failure that happens. It's not just one app going down. You end up with widespread data theft, espionage, and a complete and total breakdown of trust. When a big software provider gets hit like this, they become a single point of failure that can take down everyone who relies on them. The entire digital ecosystem feels that shockwave. Okay, so that was all pretty grim, but there is good news. There are absolutely ways to defend against this stuff.
So let's switch gears and talk about the building code for software, the rules you follow to build things safely.
The big idea here is trust, but verify. First, you only get your bricks from trusted suppliers, well-known places like NPM or PyPy that have security checks. Next, you have to constantly check your inventory. That means patching and updating your libraries all the time, because a safe brick today might have a weakness discovered tomorrow. You also have to check every delivery. Digital signatures are like a factory seal on a pallet of bricks. They prove nothing's been tampered with. And finally, you gotta lock down the factory floor itself. Secure that CI/CD pipeline so no one can sneak in and poison the assembly line.
Now, of all those things, there's one I really want to zoom in on, and it's called an SBOM. That stands for Software Bill of Materials. It is one of the most powerful tools we have. Think of it like this. An SBOM is just a complete inventory list of every single component in your application. It's a manifest detailing every brick, every wire, every pipe. That way, when a vulnerability is discovered in, say, Super Widget version 2, you can instantly check your list and see if your house is built with it. It's all about having visibility.
And that kind of brings us full circle, back to you. Every single day, you rely on dozens of applications on your phone, on your computer, and every one of them is like a complex house built from thousands of these tiny third-party bricks. So after all this, it leaves us with a really important question. Are you sure the digital houses you're living in every day are built with safe bricks?